Oh, can you guys hear me okay, or should I? Okay, cool. Hi. Yeah, so my name's also Chuck. I have a regular name too. I'm here to give a talk that looks really, really aggressive and mean. I'm a big fan of like nail bats and zombies and things like that. So that's actually the Twitter background picture of my Twitter thing. So it was easy to grab and just use for my slide. A little bit about me. The intelligence is way too high on this special chart. I'd probably put myself at a 3, but my luck's definitely a 10. This is my 5th talk at BSides Connecticut, which is nuts. For perspective, there's only been 6 of them. And my talks have gotten more and more increasingly weird and less related to what I do for work. So I think the first time I came here, I gave a talk and I was in a polo shirt and it looked nice and it was really cool and it's recorded somewhere, you can go watch it. And then I gave a talk, the next time was on hacking mobile networks, the EPC core, basically how to take down the stuff that routes all your cell phone cellular data, which was kind of fun and neat, but also work-related-ish. And then the next year I gave an impromptu, off-the-record, I'm not going to talk about it talk. I'm not telling you. Let's just say if you do something stupid, they like it. And then the last year I gave a twofer talk because I didn't have enough material for one talk. It was about hacking back at Monero miners, drive-by exploits and threat intelligence, and then I talked about how I broke into my Audi, which was kind of neat. So I'm sort of all over the place, and now this is like continuing to slide down. This year I'm just in a t-shirt and sneakers that have spray foam on them from repairing my house. And yeah, so let's get weird. I'm not sure if any of you guys, who has successfully deployed, used, tested, or tried out TLS 1.3? Or, okay, like let's do the old-fashioned show of hands. Who knows what TLS 1.3 is? Okay, good. And only like one person in the back over there put a hand up and someone over there. It's been a total disaster in terms of rollout, IETF, RFCs, all this sort of stuff. And it was fascinating to sort of watch as someone who's involved in network test and measurement that this thing could be such a fiasco and what was going on there. You would repeatedly see it sort of rolled out in the browsers and then quickly taken back, or Cloudflare would turn on and go, no, it's bad. And you'd sort of start scratching your head and sort of looking at, well, why is this happening? What's fun is if you ever are interested, you can subscribe to any IETF exchange and instantly you're now a member. You're part of the advisory stuff, right? That's how open they are about this stuff. And you can sort of sit on the sidelines and watch the arguments and banter go back and forth on their mailing lists, and it can be quite entertaining. The reality is that every time they put it out, the way that Google likes to test things is because their customers are free, they just update their browser and they sort of do a A/B analysis, they call it, right? Like, I'll turn it on and see how many failures I get and then I'll turn it back off again. Then it was sort of finally announced in August last year that it was rolled out, but as you saw from the show of hands, it still isn't rolled out. Why is it not rolled out? It's because, like I said, it breaks everything. And what was really interesting was why it broke everything. The people pushing this standard wanted to stop people looking at the network traffic going through the network. TLS is meant to keep you safe, right? Some of us might call it SSL, if you're really old. But basically, it's designed to stop you from looking on the inside. So if you go banking or something else, all that data is encrypted, does a public-private key encryption pair exchange, and then shares some sort of megalithic awesome key. And now we have ephemeral ciphers, which make it even tougher to break in. So, but what's the problem is if you're a blue teamer, if you're a network defense person, you have policy you have to enforce. You have to stop people going to YouPorn all day. You have to stop people going to known criminal websites, or Make sure that they're not downloading malware over TLS. Almost all malware is over some kind of SSL. Let's Encrypt makes it nice and cheap for them to do it, right? So if you go look at Bluecoat, FortiGate, SQUID proxies, whatever, they all have an ability to man in the middle of that network connection, and then your IT staff will ship a certificate that says that's okay, and your browser doesn't throw up an alert, right? This is sort of how this is meant to work, and in America we understand our computers don't belong to us, they belong to our company. And everyone's okay with that, and they then just buy another computer for porn at home. There's a lot of good reasons for doing this, right? Like, you do want to limit access to stuff. You want to make sure people are safe. It's a headache when people download malware. And also, it's a handy thing to use if you happen to, own the root signing certificate for .com and have a device that can intercept SSL to spy on people. So the trouble was that these guys, it somehow magically appeared out of all of this design and thought into this network protocol stack that they never even imagined that these devices existed out there or did this. And it's mind-blowing, but if you read these blogs and stuff, they're like, we found out about something we're calling Middleboxes. If you're me, you call them a firewall or, something like that. But it's amazing how disconnected you can be as a developer, a huge company like Google, and not understand that this is also happening in the same world, right? But it really looks like that's sort of what happened. So the security vendors, from what I could tell, weren't brought into this discussion until way later. The guys kept trying to get increasingly clever, but the weird screw up they did was at the top of the protocol header it says what the version is, and they just put 1.3, assuming that would just work. And all the decryption devices out there sort of assumed that 1.3 would work kind of like 1.2, and it doesn't. And so that sort of broke the whole thing. And so if you start looking at it from an even bigger point of view, these Middleboxes don't just do TLS decryption. They intercept your IMAP, they intercept your POP3, your SMTP communications. They have really neat sort of proxy mode, flow mode, whatever. And they'll even hold back a data exchange as you're downloading a email for the last file, send it to the cloud, hash it. If it's bad, it drops that last packet, and hopefully your browser doesn't stitch that piece of malware together because there's no bytes padding on the end, doesn't do anything. The other stuff that Middleboxes firewalls do is NAT. They perform fix-ups on protocols. So if you've ever had a headache where FTP isn't working or voice over IP isn't working, you haven't turned your fix-ups on. They rewrite the protocol headers for that. SQUID caches your data, so it inserts headers, it looks at stuff, and it blocks spam, right? So then, for me, and my point of view, the question that I got provoked with was, can I figure this out? Can I figure out what's between me and somewhere else for a box that's trying its best to be as transparent and get along as possible? This isn't so much identify it as, oh, it's a firewall, but I want to know what specific device that is and how many there are between me and the rest of the world. Do I have the right to know that is a follow-on question, and I think the answer to that is yes. And more importantly, can I do it? Can I figure out what these things are and how they look? So here's an eye chart for you. But basically, this is an FTP transaction across a firewall. It says FortiGate in the PCAP file up there, so you can tell that that's a FortiGate device. And if you look on the left, you'll notice that's a little shorter than the one on the right. So now it becomes an eye-watering, like, visual diff of trying to figure out which command it is that was snuck in here that's not there. Yell it out if you see it, otherwise I'll just say it right now. Size? Yeah, it's size on the right. Size is an esoteric, weird FTP command that you can issue before you do a retrieve for a file, and it'll tell you how big that file is. Now, if you're doing malware interception, why is this important? Why do you want to know how big that file is going to be? Because you open up a separate socket and it's just a binary blob of data that comes across at you, right, for that FTP transaction. It has no context to it. So you need the context of how big it is if you're going to do malware analysis on it. Because what it will do is it will snarf up all of the packets, pass them to the customer, so the customer sees their download going just fine, and it'll leave those trailing bytes, and it'll just hash that whole file. It'll ask somewhere in the cloud, is this malware with MD5? There's a reason to use MD5. Or SHA, normally SHA-256 or something. And then the cloud will come back and say, yes, this is malware, and it'll terminate that connection then. So we have our first test. I can do an FTP transaction, and if I see on the server side that size request, and I didn't send it on the other side, I now know I've got a FortiGate between me and somewhere else, right? Here's an easier one. So I can't remember which one this was, but what's interesting is there's no effort to mask any of the HTTP headers or anything. This little IE-friendly error message is built right into the thing to try to navigate around an IE bug for like IE6, where it basically just says, if you get a 404 and it's too small, it just displays the Internet Explorer. It's a bad web page rather than the page. And on the right, I was sending ICAR. So I'm testing the AV filtering mechanism here, and this is drifting slowly downwards. There we go. Okay. So this is easy to tell that the content I requested is not the content that I asked for, but that's not the question I was asking. The question I was asking is who's actually doing the blocking and what it is. So you can see different headers are inserted on as well as, oh geez, sorry, some other fun things, right? But what's also interesting is if you enable proxy mode on one of these firewalls, but you turn off all detections, you turn off all the engines, it still flips one little bit, changes HTTP 1.0 to 1.1. So now I even know if you're trying to sneak something in there and not do anything at all, I can still see you, which is kind of neat too. And then this is one I did last night. I just Googled how to set up a transparent SQUID proxy. And you can see SQUID is super noisy, puts a lot of stuff in the request. Some of my stuff is also looking at, I also looked at a lot of the TLS stuff, but that'll make you go crazy trying to see those binary blobs. So the question becomes, who watches the Watchmen? This is actually from a terrible Latin romance poem, but it's been usurped by Alan Moore. And I went and tried to figure out what's the Latin for watching the Watchmen, and I got Vigilante. So I thought, that sounds really cool, and I'll use that for a name. I wrote it in Python, because I don't know how to write Python, so I figured it'd be a good opportunity to learn how to write Python. It recognizes Middleboxes based on the traffic characteristics. So you can think of it, it's almost sort of like a procedural programmatic tool, kind of like an IPS uses regular expressions to find malicious stuff that's on a network. This is trying to find what is watching me, right? Using a similar sort of framework or idea. It's currently capable of detecting FortiGate in 2 different modes. If you've ever deployed a FortiGate, you know those 2 different modes make it operate like a totally different firewall. It also detects Palo Alto because our IT department uses Palo Alto, so that's easy to test. And as of last night, I added a little bit of SQUID detection in there too. It currently it has test cases for HTTP content filtering, AV filtering, proxy detection, TLS, and FTP. Yeah, there you go, content filtering, AV filtering, and all that. So now I'm going to try to do a demo. My laptop fan is going nuts because it's a little hot in here, or maybe just here. So we'll see how well this works out. So if I go here, I need to establish an SSH tunnel to a Jeff Bezos server. And this is basically port forwarding 3 different ports that I'm listening on so that all my software just runs locally. So now if I run, you can see I've even been working on it now. Oh, you guys can't see that. Oh my God. Ugh. What? Just yell that out right away, guys. Don't let people dangle out there when they're presenting. It feels terrible. All right. So this is going to go fast, but I added color text support, so it looks cool and amazing. And if you look here, you can see that it can detect, am I getting inspected by Palo Alto, or am I getting inspected by SQUID, or whatever. I'll scroll back up here. So if you look here, I'm testing the presence of proxies. It didn't detect any proxies. Now I'm doing clear text HTTP inspection. So here's a neat trick. Because DNS is also a dumpster fire, when these things are doing content inspection and trying to stop you going to malicious websites, most of the time they don't see the DNS traffic. Your DNS server's over here, firewalls here, users here, bad internet up here, right? So instead of using DNS queries to block stuff, they look at the HTTP header, they look at the certificate name, the SNI field, the whatever, like those sort of network artifacts instead, right? So all you have to do is pick a server on the internet and then issue a GET request in the host header that says playboy.com, and it'll nuke it. So that's like the easiest way to test one of these things. So what I did was I generated a list of places that I figured you might want to stop people going to. Playboy.com, Google.com, example, CNN, Board Game Geek. They block my board games at work. This is number 1 reason why I set up a Tor proxy. I just want to find out when Magic the Gathering is draft night is at 6:45 or 6:30 to take my little one to, and they block it. Price Clearinghouse, they can block that. Screw those guys. And then it's kind of neat. Runs a shell script that generates new TLS certificates every time you run it. These are fake TLS certificates, but they put in the right certificate name, SNI headers and stuff. And then it puts those in there. I wrote basically like a fake TLS handshakey thing that pretends to do 1.2, which was lots of fun and a huge headache. If you've ever done ASN.1 parsing, no. And then at the bottom here, I've got an FTP filter, the FTP filter test, and the only one I've got a test for that is the FortiGate right now. And then this one doesn't have the sexy syntax highlighting, but you can see that the AV filtering was caught down there, right? So that's on a pan, and you can figure that out. But then it gets cooler. But wait, there's more. So this is the Linux box I set up SQUID with. Am I still connected to that machine? I am. Good. So hopefully you guys can see that. It's a little smaller, I know. But this is basically a Linux box. It's got a SQUID server set up, and it's forcing all the traffic through that SQUID, and then it's going to go through my VPN at work. So now I can see if there's 2 devices layered on top of each other and who's doing what, which is kind of neat, right? So if you look here at the top, it figured out that, what did I say? Your browsing is being inspected by SQUID, transparent proxy, mostly used by airlines and cheap net ops. And then further down here, it says that your playboy.com is blocked by the PAN. So you can actually sort of see who's blocking me where, which I think is really neat. So that's the demo part. I think it's kind of cool. I don't know. And so now we have the necessary concluding slides and things. So let me try to explain how it works. I won't lie, I made this about 20 minutes ago. Because I realized that there's a lot of voodoo going on in there you might not recognize. But basically, here you are over here with your computer. And what I do is I set up an SSH tunnel to an AWS instance, the world's tiniest computer I can find. And I say, do remote port forwarding from there for 8080, 8443, and 2121. You can recognize those all as like alternate ports. I don't have to do user privileges or anything. And then I set up IP tables to forward 80, 443, and 21 down to there. And then I run test cases one at a time. I do comparisons of what I sent, what I received on both sides. So my test cases, the function absorbs it, says, here's the original sent, here's the original received on the server, and here's the original sent by server, here's the original received by client. It's working so far. And I'll just keep adding in new fix-ups for it as I find problems, I guess. The code is gross, so I'm not sharing it. I really want to test a Blue Coat TLS device. Did manage to find one for $100 on eBay, but I haven't found the time to set it up and probably doesn't have a license on it. So, boo. SNAT detection. If you saw, it's like I call these test cases layer 7, but I also want to have source NAT detection using Scapy or some other packet crafting tools. You can see the same sort of little network artifacts and identify if you're using pfSense or FortiGate or PAN for doing your NAT. They all rotate source IPs differently and source ports and things. Instead of using SSH for port forwarding, which is really cool, I should probably learn how WebSockets work to make it a little easier to set up and run. And then I don't have to rely on SSH working and not being inspected. Which leads me to the last one. I want to know if SSH is being intercepted as well, because how many times do you just type yes when you're logging into your server and it says new key, and you're like, okay, I gotta get work done. I guess it's right. Who knows? So why did I make this? This is the obligatory pontification slide. I had an itch to scratch, I guess. I was like, I have to deal with this in my work somewhat. I have to make these application protocols work for testing across firewalls. So I'm already learning how these things all work. Can I apply that in some other way? I was reminded of a college roommate who took a map of the lakes region of northern Minnesota. I don't know why he had that on his wall. I went to school in Worcester. And he scrawled on it in giant Sharpie markers, the map is not the terrain, probably in a fit of madness. It was college. Use your imagination. So the point is like, even on my way down here today from New Hampshire, knowing where you're going and knowing where you are doesn't tell you what's in front of you, right? It's not telling you how you're getting there. It doesn't tell you where the toll booths are, the police are hiding, that there's a pothole, or, breakdown. Some of this stuff, you can use Waze now, right? They sort of enhance, and they're giving you terrain data now, right? But it's really that. If I'm driving, I can see what's in front of me as I'm going to my destination. On the internet, you know where you're going, but you don't know how you're getting there. It's a giant black box of, I don't know. And I figure people have a right to sort of figure that out. Like, what's going on between me and the rest of the world? And how could it impact me? And I'd like to know if they're doing that. So I got 7 minutes left if you got questions. But basically, you can follow me on Twitter at Nobletrout. I'm part of like 3 random people in Massachusetts that are trying to start a ski/security convention thing up in the White Mountains this winter. It's going to be a total disaster, and I'm going to love every minute of it. So, if you're interested, follow the SkiConNE Twitter handle. I look forward to seeing some of you guys there. I'm going to imagine there's going to be a lot of beer and worn out people. So it'll be good. That's about it. Thank you. Yeah?
Did you ever take a look at the way that some of those TLS certs are generated by the...
Yes, I did. And I didn't put it in here, but yes, I did. So actually, I can show you that if you want to see it. Let me see here. I happen to have my private GitHub repository right here. Here we go. So it's a bunch of binary blob comparisons, but basically, if we look down here, there you go. So this is sort of what you're dealing with, basically, right? What's kind of neat, let me see if I can find it here. There we go. So the pan takes the random thing in the TLS handshake, and it just decrements the first byte by 1. So my test string is kafifi, 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 and it becomes bafifi, kafifi, kafifi. So that you know, this is the sort of stuff that I'm trying to do to make it hard. I set up because there's a lot of backscatter. Almost all my requests, I try to smuggle a UUID in there, and I pattern match on that to know that I'm talking to me. Otherwise, it can get confusing.